Okay, so looking at the first of the videos for this last topic, and it's called minimum spanning trees. Okay, so you've done trees before, but a minimum spanning tree has many applications because we're kind of trying to find the smallest number of edges to connect the vertices. So it could be to do with costs or distances or whatever, but the smallest number is always the most economical. So the cheapest or the smallest spanning tree for these networks is called the minimal spanning tree, and what the problem must be done is expressed as a weighted network. So weighted just means there's numbers on the edges, and these numbers could represent something that we're measuring. Okay, so what we measure is called a quantity. Could be dollars, could be kilometers, it could be something, but we're measuring something. Okay, copy that and come across. Okay, so we're looking at a shortest path algorithm. Now this big word here just means steps. So we're just going to try to find a step method to find the shortest path, and we're going from some starting spot to some finishing spots. Okay, we're going to try to find the shortest distance along, and these are the steps we're going to follow. So I just want you to copy them down and we'll do a worked example. So from the starting vertex, we're going to find the shortest distance to all those that connect to that starting spot, and then we're going to create a set. Okay, so S is a set of vertices, so we're going to start from A, we're going to connect B and C perhaps, okay, and then we're going to choose a vertex that connects to the set that we've got, and that we're going to try to find the shortest path from that starting vertex using the vertices that we've already started with, and we're going to add this new vertex to the list. Okay, so the list is going to keep building and building until we finally get to the finish, and we're going to keep repeating that step until we get all the vertices in the set, and then we're going to find the shortest path. So copy that down. It looks complicated, but we'll work through an example and see if it makes sense. Okay, copy that down. Okay, so I've got a excuse me, a tree. I don't know what it represents. It could be distances, could be whatever, and we want to go from vertex 1 to vertex 9 in the shortest distance possible. So on the diagram, blues are vertices and the distances are in green. So from 1 we can get to 2 to 3 and to 4, but we can get to 3 directly or going via 2. So that's why there's this extra step here via 2. So what you do is just look at the graph and just write down the numbers. So 4 for the first one, directly is 8, but indirectly 4 plus 3 is 7, and to get to 4 we have 6. So the shortest distances to get to 2 is that one, to get to 3 is that one, and to get to 4 is that one. So far the set is, we start at 1 and we've done the 2, the 3 and the 4. So the next vertex in the set is vertex 5, and we'll do 6, 7, 8, 9, and this is the last answer obviously. So to get to 5, which is down here, we can go via 4 or we can go via 3 to get to 5. So to go via 4, it's 6 plus 9 equals 15. And the shortest distance to get to 3 was 7. And then we're going to go 7 plus 7 is 14. So the shortest distance is 14. So now our set is 1, 2, 3, 4, and now we've included number 5. So eventually we'll have all of the letters in this set down the bottom. The next vertex is number 6. So to get to 6 we can go via 2, we can go via 3, or we could go via 7. So we go down to here and then back up. So it doesn't matter how we get to 6. To get to 6 via 2, to get to 2 we had 4 up there, and then it's going to be 4 plus 7 equals 11. To get to 3, the shortest distance to 3 was 7, and then we're going to go up that path, so that's 3, which is 10. And to get to 6 via 7, we've gone across the bottom, and then we've gone up. So we've got 8 plus 9 plus 2, which is 19, so that's not going to come in. So the shortest distance is that one. So now our set is 1, 2, 3, 4, 5, 6. Okay, to get to 7, we could go via 3, we could go down via 6, or we could come up via 5. Okay, so the shortest distance to 3 was the 7, and then we're going to go up to 7, across the 7, sorry, so that's going to be 9, so we've got 16. The shortest distance to 6 was the 10, and then from 6 down is going to be 2, so we're up to 12, and the shortest distance to 5 was the 14 answer, and then from 5 we're going to go up to 7, so it's 4, so it's 18, so 12 is the shortest distance. So now we've got 1, 2, 3, 4, 5, 6, 7. Okay, to get to 8 is okay, so 8's the next vertex, so 8's up there, so we can go via 6 or we can go via 7. So the shortest distance to 6 was the 10 answer, and then we're going to go across the top, which is 5, so that's 15. The shortest distance to 7 was the 12 answer. Okay, shortest distance to 7 was the 12, and then we're going to go up 4. So we've got 16, so 15 is the shortest distance. So now we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're at 15. And then to get to 9, we can come via 8, we can come via 7, or we can come via 5. 8, 7, or 5. So the shortest distance to 8 was this answer, so it's 15. And then we're going to go down 3, so that's 18. The shortest distance to 7, was the 12 answer, and then we're going to go across 2, so that's 14. And the shortest distance to 9 by 5, so the shortest distance to 5 was the 14 answer, and 5 then goes up by 12, which is 26, so 14 is going to be the answer. So now we've got all the letters 5, 6, 7, 8, 9. So our shortest distance algorithm will now be, we started at 1, we went to 2, we went to 3, and then from 3 we went to 6 to get the shortest distance, then we went to 7, and then we went to 9. So that's the shortest distance, and that equals 14. Okay, so there'll be an exercise to do on that. Thanks, bye.